Awesome, awesome. Well, welcome back to the Red Hat channel. We're glad that you've joined us today. Happy holiday week. If you're back home or wherever you are, feel free to put that in chat where you're calling or you're joining us in from for today. Now, we've got a very special episode today on Demo Deep Dive. And if you haven't joined us before on Demo Deep Dive, this is a really fun show and experience because when we talk about open source and we talk about all of these technologies like virtualization, AI, containerization, and much, much more like Linux and Ansible, well, we don't always get to see the behind the scenes and how the technology actually works. So the purpose of this show is to show you behind the scenes what's happening with these open source projects and some of the products that Red Hat works on. And to do so, we bring in various experts every week. And so I'm honored to be joined by Alan Cowles, who is a technical marketing manager. And Alan, feel free to introduce yourself and to let us know what you've been tinkering on or what you've been working on recently.
Hey, Cedric, thanks for having me, man. So as Cedric said, I'm a technical marketing manager here at Red Hat. I'm part of the OpenShift BU, where I focus mainly on OpenShift virtualization, along with storage, backup, and recovery integrations with a lot of our OEM partners out there. So most recently, and I think what is our subject for today with the demo deep dive, are some of the new features that were most recently introduced with OpenShift 4.20. And along with that launch, we prepared some of what we call interactive demos through the arcade software that allows users, if they don't have an actual OpenShift environment in front of them, to experience what it's like to actually check out some of these new features. So it's kind of something we're going to look at today.
Awesome. And yes, super excited that you've prepared some of these new features for OpenShift 4.20 that we're going to be taking a look at today. And as Alan mentioned, so if you go to interact.redhat.com, or if you scan that QR code in the top left of the page, you can actually check this out for yourself, including what we'll be working through today with the new features on OpenShift, but also a lot of other demo experiences that you can check out from, as I mentioned, AI or container management or virtualization and much, much more. So feel free to check this out. There's a lot of different experiences you can take a look at that show you how the technology works. And it's just a cool experience. So feel free to check that out. But without further ado, I think it's time that we go ahead and hop into what you've prepared for us today with OpenShift. And I guess that's a fair question to ask. Alan, what is OpenShift? I mean, it's such a popular and widely used container platform, but like, what problem is it solving for developers and engineers?
Well, I think OpenShift, your overarching description of it is that it's a fully equipped application platform. So it benefits the developers and those that are trying to run production workloads, whether they're in containers or in virtual machines, right? I don't know if I want to say this right, but it's based on Kubernetes. So Kubernetes on steroids. I think the best way one of my favorite ways to describe it to somebody is if Kubernetes is Cheerios, then OpenShift is Honey Nut Cheerios. And once you got the Honey Nut, man, it's hard to go back to those plain ones, right? So so yeah, I guess that's the basic overview of what OpenShift is. Now, one of the benefits of OpenShift, and of course, any open source software supported by Red Hat, is how quickly the development cycle runs with community support and things like that. How quickly we can address, any bugs that might appear or introduce new features. If you're not familiar with the release cycle to OpenShift, it gets released 3 times a year, every 4 months. So the most recent release, OpenShift 4.20, came out just last month, back in October, and introduced a number of new features that a lot of our customers have been, specifically asking for or interested in. So, using the arcade tool through the Interact portal that Cedric, you covered just a second ago, we've actually, created some of these demos to show off some of these new features. And the screen I'm sharing with you right now is, a large look of the demos that we prepared to show off these new features. And we're talking from the Red Hat build of Q, an introduction to UDN, user-defined networking with BGP that helps you map back to private networks, Zero Trust Workload Identity Manager, an update pre-check that is something that a lot of our big customers are interested in when they're running production workloads, so that they know when they're going to that next rapidly released version, they can make sure there's no hangups in that upgrade process, right? An OpenShift cluster traditionally is 3 control plane nodes, but we've actually introduced a new 2-node with an Arbiter that will help for smaller form factors if people are interested in that. So, there's an overall view of all the new features that we have out here. Now, with the time that's still left here in our webcast, my intention is to pick out a few of these. I've already got some tabs pulled up here in the corner, but we're going to kind of like step through those demos and talk through the processes, if that's okay with you.
Yeah, I think that's perfect. And just before we hop in, if you're joining us, online live right now, feel free to ask any questions as we're going along, because, we're super passionate about this, about OpenShift, about containers and open source. So if you have any questions as we're going along or comments on what we're showing, feel free to let us know that in the chat, and we can bring it up screen and, have a great time. So I think, Alan, it's a perfect time to go ahead and start with these impressive new features. I'm really excited to see what you and the team have been up to. Sure.
Like I said, as I was given credit for, I created a couple of these demos. I did not do all of them. It was a massive team effort to bring all of these in around the time of the software launch. I'm actually going to start off with the demo around the 2-node OpenShift with Arbiter, because I think that new smaller footprint is something that is attractive to a lot of edge or edge data center clients that still want an HA deployable system, not the single node OpenShift we've had for a long time, but to still have an HA deployment. And of course, you can see this one was actually created by Paul Lancaster and Daniel Froelich. So when it comes to arcades, the way they're set up is they're embedded in the web portal. You can see there's different chapters along each thing here, but we can step through, and we're going to start this one just by clicking the Get Started button. And so it's going to play interactively, and I'm going to let them talk.
Sweet. And if you want to make it full screen, feel free. Awesome. Okay. Don't know if we can hear.
I think I lost the audio when I went full screen. Yeah, it's.
Oh, okay. My apologies.
Which we still got subtitles, and honestly, I can talk through the process. That was my intention, anyways. I honestly did not know that there was an embedded video in this one, so that one caught me by surprise.
Don't worry.
So at any point, you can introduce slideware into these demos, as you can see Paul has chosen to do here, but you can also have the interactive demo for the OpenShift console. So I'm just going to pause it right here with the play button. And as Paul's saying, we're looking at what is now a 2-node solution for cost-sensitive customers that still want to have that HA deployment, right? So the idea right now is that there are 2 physical nodes where where the user's workloads live, where infrastructure services and Kubernetes services live. But etcd, the brains behind OpenShift, the stable state that makes Kubernetes work, normally requires 3 instances to be in Quorum. In this case, we find that 2 instances live on the physical nodes, and then the 3rd instance is not a full OpenShift node. It is actually a small Arbiter instance, many times virtual, 2 vCPUs, 8 gigs of RAM, so not a huge on-taking for hardware. And all it does is provide that Quorum instance for etcd, that 3rd instance. But as this says, you get the same HA characteristics as a regular 3-node cluster. It is supported on x86 and ARM on bare metal servers.
Nice.
And it does give you the ability to fully support OpenShift virtualization. And again, that's where it comes in really handy to have that HA ability. You know, you want to be able to take virtual machines, you know, like other popular hypervisors, and be able to fail them from one node to the other in case something, you know, is gone awry there.
Right. And so that comes back to so HA, just for clarification, that's what, high availability?
That is high availability. Yeah. So it's in the case that if one node were to fail, the workloads that were running there can restart over on another node in rapid succession. So the main difference that this provides compared to a single node cluster in OpenShift is that a single node OpenShift environment, which is one node that runs both the control plane and the workloads, that cluster can be expanded by adding other worker nodes. However, it is still not an HA appliance because there's still only the one copy of etcd on the control plane, and HA features like automatic failover are not supported even with the additional worker nodes. So you're kind of stuck in that environment. What this gives you that ability to do is have that HA ability, and then you can choose at a later point to scale this into a full cluster if you decide to.
That's very cool. Awesome. Yeah, I definitely see the use in that. And if you need that, you know, smaller, but still high availability environment for your applications to run.
Right. So I'm going to let this demo continue playing through the slide here for just a moment. And we'll see as we get to the next step, we're going to bring up the console and we can actually take a look at what this looks like from within OpenShift.
Sweet.
So here's our OpenShift console. And you can see that we are running OpenShift 4.20. It's actually a release candidate. One of the things that happens when you're trying to prepare these demos for launch day is you don't actually have that, you know, release code, that GA. So we have to prepare these demos with the release candidates, the things that, you know, what's still kind of in the oven ready for that bell to go off, right? So here, what Paul's doing is you see the standard OpenShift cluster. You see, as it's mentioned, it's running on bare metal. And as I mentioned, it's 420. But you can also see that it shows there are 3 nodes in the cluster inventory. That's kind of interesting because the whole point here is not to have 3 nodes. So let's see what we're going to look at. We're going to click on Compute and Nodes. And what we see is that we actually have Compute Node 0, Compute Node 1, but then Arbiter node. And it's specifically set to the role of being the Arbiter. So the role for these 2 nodes are that there are control planes and worker nodes. And you can see the resources on each of those. But you can also see the minimum resources required on this Arbiter node right here. So it does kind of stand out that that node stands apart and just provides the HA, you know, the quorum for the etcd service.
And Arbiter, that just means like a kind of like a proxy, or what does it mean in this definition?
In this, so in the case of etcd and there are several other IT, you know, compute services out there designed where they run an odd number of services to decide the status of the cluster as a whole. If you only had 2 nodes initially, you could end up in what we call a split brain scenario, which each of the 2 nodes, while running a copy, does not know who's actually in charge and what the true state of the cluster is. So by having that third available as a tiebreaker, that's where you get this true source, the source of truth. You see this very popular with like the network time protocol, NTP, right? If you're querying an NTP server out there somewhere and you're saying, you know, what time is it? And server 1 answers it's 12:42, and server 2 answers it's 11:15. Well, which one's right? You know, so server 3, oh, it's 11:15. Okay, so we know server 1's got an issue over here, but you know, we got 2/3 majority, super majority over here telling us what to do with there. So
crowdsourced.
Right. So that's the gist of this demo, is the fact that we now have that HA ability in the smaller footprint for cost-conscious customers. Gives us the ability to get this deployed in those smaller form factors at the edge data center.
Awesome. Well, thank you so much for walking us through it. I know there's a couple more that if we have time, we want to get through, like virtual machine load balancing, because I know we've kind of been talking about that controller as well.
So this one is, I'm going to say, really exciting. I did mention, though, that I'm kind of biased. One, I created this demo. Two, virtualization is, my area of expertise right now. This is something that people coming from other hypervisor environments that are deciding to adopt OpenShift have been really excited about for a while. And it's something they've been asking for. I want to say they were first talking about it maybe a year ago. And in the last couple of cycles, we've gotten it out and available. But the whole point here is that Kubernetes normally schedules your workloads based on the resources that are available on each node in the cluster, right? So when you create a virtual machine or a containerized application, you request the resources needed, and Kubernetes, OpenShift, decide where that needs to go, okay?
Mm-hmm.
And it finds the best node possible at that point in time and decides that's where to put it, okay? Prior to the need for virtual machines, so let me describe this a little better. Normally, containerized applications have multiple replicas, right? So those replicas will be sprayed across the cluster. If one node gets overloaded, it will actually just kill one of the replicas. Now the application is still up, the services are still available, but that overloaded node will be relieved of one replica. Then that replica will respawn elsewhere where the resources are available in the cluster. However, in virtual machines, you don't have multiple replicas. You don't have a pool of VMs. You have the one instance, right? And as gentle as it may want to be, if you kill that instance to relieve a node, you lose access to it. You lose access to the services, things like that. So we really need to avoid that. We really need, and we have the functionality available with live migration between the nodes where a guest can migrate to another node. Normally, that is a manual process. With this new feature in OpenShift 4.20, when a node comes under intense CPU pressure, it will decide to automatically evacuate the virtual machines to another node to kind of load balance the cluster, okay? So that's what we're going to demonstrate here. So you can see we are in OpenShift 4.20. I did my demo a little different. I didn't do an overarching audio introduction. Mine's got prompts and asked you to click through the process. So we're going to click here and check out the virtual machines on our cluster. And right now, we have 42 machines that are running here, okay? So if we click on all projects, that shows us there are 42 machines. If we click on that, we get the list of all 42, and they are currently selected. And if we use the filter drop-down, what we'll see is that those 42 machines are all in the running state, and they're currently spread across 4 worker nodes. Now, if you notice, these worker nodes are not balanced by the number of actual VMs, okay? But they are balanced by the resources required for each one. So worker node 6 has 19 VMs placed there, but they're more smaller, less resource-intensive VMs. Whereas the other 3 nodes all have more similar numbers, 8, 7, and 8, larger, more resource-intensive VMs, okay? So, it's distributed. Like I said, OpenShift Kubernetes, it places them based on the resources that are available at the time that that resource request is made, based on the best node for placement. So we're going to just pop through these real quick, and you can see how Arcade just lets you kind of look at what the console provides. So now what I've also got in this cluster, because this cluster is set up to demonstrate this purpose. There are more than 4 worker nodes. I actually have 5 worker nodes, okay? So node 6 and node 7 are part of this cluster. But you can actually see by the resources being used here, very little memory is being used on node 7. Very little CPU is being used, okay? The reason for that is on worker node 7, for the purpose of this demo, I actually put what we call a taint on it to say that you cannot assign virtual machines here. I don't want virtual machines on this node. I've now removed that. So we're down to 0 taints, and we're going to go back now that OpenShift and Kubernetes have realized that, hey, here's a free node that's not being used, and I'm being overwhelmed on resources, but hey, here's what do you want to say? Fresh food, right? Like fresh meat. We've got the 42 node machines still running, but if we take a look at our filter now, again, we're still at our 8, 7, 8, and you see this section's a little bit longer right here because it's polling. The way this cluster is set up, every 30 seconds, it is polling to see how we're doing for resource utilization and what's available in the cluster.
Oh,
excuse me.
And I just saw something change
here, I'm going to
before.
pause it. Yep, I'm going to pause it briefly. I'm going to actually pop back. You can see our running number went from 42 to 39. And you're like, oh no, stuff's crashed. No, it hasn't crashed. What has happened is I showed you earlier as I scrolled down that there were all 42 were in the running state. And that's what that field is showing. Currently, 3 VMs are in the migrating state. You can actually see right here, 3 of them are not migratable because they are currently migrating. You can't affect them, And we've actually see the first one has already shown up on node 7. In fact, so the first one has shown up on node 7. So 40 is now running, 1 on node 7. We should come to 41 with 2. And we actually even saw the 8 and 6. Look, this one's even rebalancing. See? So now we're down to 7, 7, 6, 19, 3. But this cluster is figuring out where it's got resources available and where to best place those virtual machine workloads. And it's still working. See, it went back to 41. Now it's back down to 40. But it's going to figure it out over the next couple of minutes. And now we've got 4 up and running here at that point. So that's the main gist of it, right? Is that, Kubernetes and OpenShift now has the ability to manage the resources that are available to it to balance out virtual machine workloads. So I think that's a very neat feature that we were able to introduce here in OpenShift 4.20.
Awesome. And so this is all powered by like KubeVirt or something like that under the hood?
Yeah. So KubeVirt is the CNCF project that allows you to run virtual machines in OpenShift. So, or in Kubernetes, but of course in OpenShift as OpenShift virtualization.
Awesome. So
I'm going to go ahead.
Oh, sorry, brother. I was thinking we could do like a quick fire round for these, like do a minute each and just kind of overview what's the new feature as we kind of have to close out in a few minutes here. What do you think?
Yeah, sure. The other 2 demos I selected here are a bit shorter. I wanted to make sure I got the 2 longer form ones up first. So this is actually another one I created talking about not specifically virtualization. It's just cluster management overall. And we're introducing what we're calling an update pre-check. So when it's time to do an update for an OpenShift cluster, you usually see this prompt right here that shows update cluster. Okay. And if you notice, I'm looking at a 4.19. This is not quite 4.20. The thing that's hard is if you want to show 4.20 the day it's released and you want to upgrade it, there's nowhere for it to go. There is no 4.20 plus on that day. So in order to show this, the actual demo is in 4.19 being upgraded to 4.20 when this was still a tech preview feature. okay? But it still shows that it functions as designed. So when we go to our cluster settings, we can see that the updates are available. I'm currently in that 419 channel, and I'm going to select the 420 channel for candidate because that's what I want to look at, what I'd like to update to. And if you notice, it will give you, I'm going to go ahead and pause it here real quick. It gives you, hey, this cluster should not be updated to 420, but I want to know why, right? It says you can continue with patch releases. So what we have here is opening a terminal, the OC admin upgrade recommend command. This is what we've introduced. So I'm going to type that command on the command line. You know, the Linux geek in me is getting really excited here, right? Because I get to command line stuff, you know. But the following conditions, they found no cause for concern in updating this cluster to latest releases. So these conditions found a cause for concern. So there is one alert, and this alert is actually the current state of this cluster is having some issues with one of the pods. So it's actually pointing out, hey, we probably shouldn't update this cluster while an issue is happening. Okay, so you probably want to fix that first. It also points out that for updates to 420, we need to have the admin acknowledge that we do want to upgrade that because there are some deprecations of some of the APIs here. So if the applications you have deployed in your cluster are making use of that particular API call, you want to make sure that application is essentially future-proofed before you upgrade. As for other sub-releases in 419, the Z releases, it's pointing out that there are no issues for me going to 416. There are no issues for me going to, for 419.16 or for 419.17. So as it said earlier, the patch releases within 419, totally fine. But it's now pointing out, you know, why we shouldn't go to 420 without at least this admin verifying the workloads and acknowledging that we are no longer using that particular API.
That's awesome.
So yeah, current cluster configurations and alerts are identified. The issues with the upstream releases are identified, and updates in the current channel are identified. And so that's it. It's pretty straightforward, you know?
Yeah, but it's good to have, you know?
Exactly. So the last one I wanted to show real quick, and again, this is a 10,000-foot view, really quick demo, is that we now have virtualization workloads able to run on ARM processors. Since we introduced OpenShift Virtualization, all workloads have been on x86. We now have the ability to do ARM for cost savings. So the idea here is pretty simple. I've got a cluster up in AWS. We're running 420. And we're going to click on our compute nodes. And we're going to see that we have our worker nodes that are available in AWS. And I'm going to click on this worker node and get its details. And we're going to see that the architecture is ARM64. Like I said, pretty straightforward. So let's go virtual machines. And we've got a couple up and running. If we actually go to the console for the VM itself, and with OpenShift Virtualization, the credentials are provided to us here. I'm going to log in as cloud user with the password. And we can see the VM is up and running and on the ARM processor. So, I mean, like I said, that was a real quick one. And I know we're running tight on time here, Cedric, so I'm glad I got through it real quick.
Yeah, man. No, this is really cool. I mean, so Linux has always had ARM support. This is now the ability to run those Linux virtual machines within OpenShift with ARM support, or how does it?
Correct. Yeah. So OpenShift on ARM has been available, like OpenShift and containerized workloads, but VMs could not run there initially. Like you said, that KubeVirt project upstream, the functionality was added to that to support ARM processors, and now it's available in OpenShift.
Nice. I think that, I mean, dude, that's a perfect example of the beauty of open source. Is like, as you mentioned, the beginning of Demo Deep Dive. It's like having this as an open source project on the upstream projects to go down to this product means that, hey, if customers or the community wants these features in the product, then that affects everybody and can help everybody who uses the project as well. And that's, that's the cool thing I like about Red Hat stuff is, like, benefits us and benefits the community. So it lifts everybody up, right?
Right. We all float together. We all sink together. Hopefully it's a lot more floating.
Yeah, with OpenShift 4.2, 4.20, it's a lot of floating. So, dude, I want to say again a big thank you. Feel free to scan that code in order to see what Alan was talking about for today, and actually see for yourself those interactive experiences on the interact.redhat.com page. And as we close out here, Alan, any other thoughts or follow-up stuff that you want to add and share with the community?
I just think, like I said, check out the Interact, the demos. Check out any other webinars we have coming up that are featuring these new features, where we're demonstrating them, showing them off. I know my good friend Andrew Sullivan has his Ask an OpenShift Admin. He's always showing off some cool stuff. So I think definitely check that out if you get a chance. And if that's it, if you're celebrating the holiday this week, everybody have a wonderful Thanksgiving break. And thanks for having me.
Of course, Alan. Well, thanks for joining us. And if you'd like to see the next demo deep dive, we'll see you back here in about 2 weeks. You'll see the notification on the channel. Make sure you're subscribed and like the video and like the live stream if you learned something today. But until then, appreciate you guys joining us, and we'll see you in the next one. Cheers.
Thanks, guys.